Hey everyone, welcome to this explainer. If you've ever literally wanted to pull your hair out over complex server management, well, you're definitely in the right place. Today, we're diving headfirst into the agentless revolution of Ansible, and we're going to see exactly why it's completely taking over the IT industry. Here is our roadmap for today. We'll track the journey from the total nightmare of manual server updates, look at the push mechanism, explore some cool sci-fi origins, and then master some essential Ansible jargon. Let's just get right to it. Section 1. The configuration management problem. Let's start with the massive headache that sysadmins have faced for decades. Imagine, just for a second, looking at a fleet of 50 or maybe even 100 servers. Your boss tells you to manually install Linux, update specific packages, check connectivity, and make absolutely zero mistakes on every single one of them. No pressure, right? Doing this server by server isn't just tedious, it is incredibly prone to human error. When we do repetitive manual tasks, well, mistakes just happen. It's inevitable. So, to solve this literal nightmare, the IT world introduced configuration management. This is what brings the whole concept of infrastructure as code to life. Instead of logging into 50 servers individually, which, let's face it, nobody wants to do, a single tool reads your code and configures everything across your network automatically. Moving on to Section 2, Meet Ansible, the push tool. Older configuration tools certainly automated things, but they did it in a rather complicated, heavy-handed way.
Let's look at that old way of doing things. It required a really complex architecture. You had to set up a dedicated workstation, hook it up to a master server, write these incredibly complex scripts, often called recipes, in a programming language like Ruby, and then upload them. But here's the absolute worst part. You had to install a piece of software, a client agent, on every single node you wanted to manage. That agent just sat there, constantly running in the background, endlessly pulling the main server to ask if there were any new updates.
What's really fascinating is how the source material compares this to types of employees. That older pull mechanism, it's exactly like a frantic, hyperactive employee running to the boss's desk every 5 minutes asking, "Got work for me? Got work for me?" It creates so much overhead. Ansible's push model, though, is like the calm, highly efficient, maybe slightly lazy employee who sits quietly until the boss explicitly hands them a task. It acts exactly when told. No sooner, no later. And that brings us to Section 3, the agentless architecture advantage. This is really Ansible's superpower. The absolute most crucial point here is this. Because Ansible uses that push model, there is zero need to install a third-party client agent on your nodes. It is 100% agentless. Instead of maintaining this complex web of software, the central Ansible server simply communicates directly with your servers using SSH. Yep, Secure Shell, the standard, highly secure protocol you already have built right into Linux. The server just pushes the updates over SSH exactly when needed, and boom, you're done. No extra baggage on the receiving end. This brilliantly illustrates why going agentless is a massive win for security. Think of installing a software agent on your server like hiring a human security guard. Sure, they're there to help, but what if they get compromised? What if they accidentally leave a door unlocked? They introduce a vulnerability. Ansible's direct SSH approach is way more like installing secure CCTV. You monitor and manage things straight from the source. There is no middleman agent that a hacker could potentially exploit to get into your system. All right, Section 4, the origin of Ansible. Before we weigh the pros and cons, let's take a quick, super fascinating detour into where this tool actually got its name. You've probably wondered at some point, what does Ansible even mean? It's not some dry tech acronym. The creator actually named it after a fictional device from a 1980s sci-fi book. In the story, this device allowed for instant, zero-delay communication across vast galaxies, literally talking between Earth and Jupiter without any lag whatsoever. The timeline of how this happened is pretty cool. The concept lived purely in fiction right up until 2012, when developer Michael Dehan brought this idea of instant communication to reality by creating the Ansible software. It was so incredibly lightweight and effective that tech giant Red Hat scooped it up in 2015 to push it out to enterprise data centers worldwide. Section 5. Pros, cons, and the future. So, is Ansible absolutely perfect? Let's look impartially at what the facts say. On the pros side, it is an absolute powerhouse. The core version is completely free, it is remarkably lightweight, highly secure over SSH, and it uses incredibly simple YAML code. But Looking at the cons, it does have a slightly smaller troubleshooting community compared to older legacy tools. Also, because it relies on a push model, a human or an automated trigger still has to initiate that push. And finally, its graphical interface is still a bit of an evolving space.
Speaking of that graphical interface, while the command line version is 100% free for everyone, Red Hat does offer a premium graphical dashboard called Ansible Tower. This gives enterprise users a really slick drag-and-drop web interface to manage their automation. But a heads up, it comes with a price tag of around $10,000 annually. So it's a fantastic add-on if you've got the enterprise budget, but it's entirely optional. And finally, Section 6, Key Ansible Terminology. To wrap up this explainer, let's demystify some of the jargon you are immediately going to run into.
Let's start with the language itself. Older tools essentially forced system admins to learn complex programming languages, like Ruby, which, let's be honest, has a pretty steep learning curve. Ansible, on the other hand, uses YAML. That stands for Yet Another Markup Language. The main takeaway here is that YAML is a highly human-readable, plain text format. It's so incredibly straightforward that honestly, even someone with zero programming experience can look at it and understand exactly what it's trying to do.
So where do you actually write this YAML code? You put it inside a playbook. Think of a playbook exactly like you would in sports. It's your master strategy, your ultimate to-do list. It's just a single file where you define, step by step, the exact actions your servers need to take. Things like install this software or restart this service, and so on. But how does Ansible actually know which servers to send that playbook to? Well, that is where your inventory comes in. The inventory is simply a text file containing the IP addresses of all your connected server nodes. You can even organize them into neat little groups, like a developer group or a production group, so you can target your pushes with absolute laser precision. Finally, we have modules. When you push a playbook, the actual heavy lifting on the server side is handled by these modules. They're essentially pre-packaged, predefined commands that Ansible provides right out of the box. You don't have to sit there and code the complex logic of how to install a package on Linux. You just call the specific module in your playbook, and Ansible handles the whole shebang. And that brings us to the end of our explainer. The era of tedious manual server management is officially over, and those cumbersome agent-based tools are rapidly becoming a thing of the past. The real question is, in a world where infrastructure can be pushed at the speed of code, what incredible innovations are you going to build with all that time you save? Thanks so much for joining us, and keep exploring.